Example 2 on how to use trig. Like all problems of trig, you need to start by drawing the mustache through the given angle. The given angle is the one that's not the 90-degree angle. So I'm going to draw me a mustache here. I should be touching the hypotenuse, the angle, and the adjacent side. We laugh at trig. So this is my hypotenuse, my angle. This would be my adjacent side. That only leaves one trig name for down here, and that would be opposite. Now, once I have those, I can also use small letters to label the side. Big X opens up to side little x. Big Y would open up to side little y. And big Z opens up to side little z. Now that I have my mustache on here, I can run through the idea of sine, cosine, tangent. I should be able to throw one of these ratios out. I'll use the paper from one of my other examples. So I've got my sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. When I look at this, I don't have the hypotenuse or the adjacent side. Oh, I do have the adjacent side. It's 15.2. I don't have the opposite side. Pardon me there. See, I've got this value. I might as well write it in here. 15.2. I don't have the opposite or the hypotenuse. The trig function that uses opposite and hypotenuse is sine, so I can throw that out. I'm going to throw that one out. Now, I know for these first two examples I threw out sine. The reason why I'm doing that is because it shows you the different setups for the other trig functions. You might be throwing cosine out. You might be throwing tangent out. It changes from problem to problem. So on this one we're throwing sine out. I'll start with cosine. Cosine 46 degrees would have to equal adjacent over hypotenuse. So I'm going to call it 15.2, since I have that value, over this unknown value, which we'll call zebra. To solve this, from the first example, I told you if you have that variable on the bottom, we can just swap those out. So you bring that zebra up, and we'll call it 15.2 divided by cosine 46. It is important, if you're lending your calculator to other kids, particularly older kids, you need to always check that you're in the right mode. See how this says degree? So I am in the correct mode, and I can simply type this in here then. I can go 15.2 divided by cosine 46 degrees, and I hit enter. It gives me a value. It tells me that z is equal to 21.881. Round appropriately. Now, I threw sine out, I used cosine, I should be able to set up my tangent. Tangent 46 degrees. It's going to be the same ratio that we have on this piece of paper that you need to commit to memory. Tangent is the opposite over the adjacent. Opposite is y, adjacent is 15.2. So I say y over 15.2. With this setup, with the variable being on the top, I can simply bring that 15.2 over, and this will be a straight multiplication. And so I take my calculator, and I take 15.2 times the tangent 46, and that gives me 15.740. 15.740 is equal to y. Now I'm going to go up to my triangle and I'm going to fill in some information. I just found z to be 21.881. No surprise there. Y was 15.740, and this missing angle, these two angles, a given angle and the other one, should always add up to 90. So if this is 46, this one must be 44. And then you can do a quick check for the reasonableness of your answer. There should be a type of ratio or proportion that's running on here. If this is my smallest angle at 44 degrees, this is my smallest side at 15.2. 46 degrees, pretty close to 44, opens up to a 15.740, which is close to the 15.2. That wasn't really a surprise there. And then your biggest angle, 90 degrees, was opening up to the biggest side. There's a second example on how to use trig to solve right triangle trig.